Okay. So, the next topic which we are studying is electric potential energy. Okay. So, what is meant by electric potential energy? The amount of work done to assemble a group of charges, and that amount of work done is stored as potential energy inside the charges. Are you able to understand? And that energy stored is nothing but electric potential energy of the charges. Very important concept. Let us try to understand this one by taking an example. See here. So this is point A. Consider this is point B, and consider this is point C. So all these points or all these charges are, instead of A, B, C, let us do one thing. Let us call them as, so this is a charge Q1, this is charge Q2, and this one is a charge Q3. Clear? So separation between them was, separation between the charges is infinite. Initially, there is a huge separation between the charges. Clear number? So distance between Q1, Q2 is very large. Distance between Q2, Q3 is very large. Distance between Q1 and Q3 is also very large. They are present at infinite separation. Okay? Now what I will do is, I will take this charge and I will place it at point A. Okay? Now this charge is brought from this point to this point. So let us call it as point A, and the charge is brought up to here. Are you able to understand? Now in bringing this Q1 charge from a distance of infinity to this point A, can you say how much work I have to do, ma? Anybody? Huh? Zero work. Why zero work? See, in bringing this charge up to here, there is no repulsive force acting on this Q1, no? Where charges ఏవి లేవు కదా. There is no force of repulsion, there is no force of attraction also. Then why you have to apply force? మనం ఎందుకు ఫోర్స్ అప్లై చేయాలి? మనం ఫోర్స్ అప్లై చేయాల్సిన అవసరమే లేదు. Are you able to understand, ma? To bring this charge from infinity to this point A, we need not do any work. So work done is zero because we need not apply any force. Are you able to understand? See, for example, to lift this pen upwards, I have to do some work, no? What is the reason? Because gravitational force is pulling this pen, no? To oppose that force, I have to apply some force. But here there is no force of attraction, there is no force of repulsion. So, to bring this charge from infinity to this point A, I need not do any work. So, I can say W1 will be how much, ma? W1 will be 0. Clear, no? Next what I do is, I take this second charge and I will place up to here. Clear, no? So let this be point B, and I am placing charge Q2 at this position. Now let this distance, let it be R12. Okay? So distance between first charge and second charge, I am assuming it to be R12. Now, shall I need to do some work or not? ఇప్పుడు వర్క్ చేయాల్సిన అవసరం ఉందా లేదా? I have to do some work. Why? Because these two are positive charges, no? So in between them definitely there is some force of repulsion. Force of repulsion ఉంటుంది కదా. To oppose that force of repulsion, definitely I have to apply some force. Force is also there, displacement is also there, no? So definitely work is present. Are you able to understand? Now can you say, how can I calculate this W2? Work done on the second charge to place at this position B, how much work I have to do? Work done formula yesterday only we studied, no? Work done is equals to potential multiplied by the charge which you are moving. Clear, no? So here at this point B, who will give the potential? At this point B, who is giving the potential? Charge A is giving the potential, Q1 is giving the potential, no? Are you able to understand, ma? At this point B, Q1 will provide potential. Because when I take that charge from infinity to this position, force is applied by Q1 only, no? Repulsive force is applied by whom? Q1. So Q1 is providing potential at this point B. So therefore potential at that point multiplied by the charge which you have moved, that is nothing but work done. No? Work done is nothing but potential multiplied by Q2. Potential difference between infinity and this point B is nothing but VB. Okay, ma? At infinity potential is 0. Here potential is VB. Who is giving this VB? Here at this point, who is giving the potential? Q1 is giving the potential. Are you able to understand? So therefore, potential difference at this point B multiplied by Q2 will give me the work done. To do what? To shift that second charge from infinity to point B. Clear, Nama? Okay. Now can you say potential at point B will be how much? That also I have to calculate. Potential at point B is how much? Potential formula, potential due to point charge. Q by 4 pi epsilon naught into R. Clear, no? So at this point, this charge will give how much potential? It will give Q1 divided by 4 pi epsilon naught into R12. This much of charge it will give, no? Potential given by Q1, so Q1. Distance between these 2 points is R12, so R12. Clear, no? Multiplied by Q2. Clear, no? So therefore, what is the total amount of work done? Total amount of work done W2 is equals to Q1 Q2 divided by 4 pi epsilon naught into R12. So this is the W amount of work done to shift a second charge from infinity to point B. Is it clear? Okay. Now, what I will do is, I will shift another charge to point C. Clear, Nama? I have third charge also, no? I am shifting third charge also to point C. Now here the amount of work done is W3. Are you able to understand, ma? Here the amount of work done is W3. Now can you say W3 will be how much? Anybody? Huh? Huh? How can you say? Say it properly, try to explain. Sima, first of all, let us write the distances. This is the third charge, Nama. This distance, I will call it as R13. This distance from second charge, I will call it as R23. Okay? So, Sima, work done to shift third charge is nothing but potential at point C multiplied by the charge which you are moving. That's all, no? Ante kada? Work done formula endra potential into charge. Clear, no? I am shifting to which position? Point C. So potential at point C multiplied by the charge which you are moving. That is the work done. Clear, no? Now at a point C, who will give the potential? Both charges will provide potential, no? At a point C, first charge is also giving its force of repulsion. Second charge is also giving its force of repulsion. So therefore, at a point C, both A and B, both of them, they will give the potential. And potential is a scalar quantity or a vector quantity? Scalar quantity. So you need not take the resultant, no? Resultant you need not take, just add them, that's it. So therefore, how can I do? W3 is equals to, clear, Nama? Potential because of Q1 is how much? Q1 divided by 4 pi epsilon naught into R12. Clear, Nama? Plus potential because of second charge is how much? Q2 divided by 4 pi epsilon naught into R13, Nama, this one? 13. This is 23 multiplied by Q3. That's all, no? So have you understood, ma, why we have written like this? Huh? This is the potential because of first charge at point C. And this is the potential because of second charge at point C. Multiplied by the charge which you are moving. Which charge you are moving? Q3 charge. Satisfied? So therefore, W3 is how much? W3 is equals to Q1 Q3 divided by 4 pi epsilon naught into R13 plus Q2 Q3 divided by 4 pi epsilon naught into R23. That's all, no? Clear? Now, to shift first charge, we are not doing any work. To shift second charge, I am doing this much of work. And to shift third charge, I am doing this much amount of work. So therefore, to place all these charges at a configuration. Configuration means what? Arrangement. So I am placing first charge, second charge, third charge at a configuration, no? So this total amount of work which I have done, that will be stored as potential energy inside the system. Are you able to understand ma? నేను లాగి మిమ్మల్ని పీకినాను అనుకోండి ఒకేటు, ఫర్ ఎగ్జాంపుల్ పీకను అనుకోండి, ఒకవేళ నా మీద మీరు కోపం పెంచుకొని ఉంటారనమాట, అంతే కదా, అంటే ఒక ఎనర్జీ ఇంకొక ఎనర్జీగా మారిపోయింది అనమాట. సో ద అమౌంట్ ఆఫ్ వర్క్ విచ్ ఐ హ్యావ్ డన్ టు అసెంబుల్ దీస్ చార్జెస్, దట్ ఎనర్జీ విల్ బీ స్టోర్డ్ యాజ్ పొటెన్షియల్ ఎనర్జీ ఇన్సైడ్ ద సిస్టమ్. Understood, Nama? Therefore, what is the total amount of work done? Total amount of work done is W1 plus W2 plus W3. That's all. Just add all of them. W1 is 0. W2 is how much? Q1, Q2 divided by 4 pi epsilon naught into R1. Okay, ma? And W3 is how much? Q1, Q3 divided by 4 pi epsilon naught into R13 plus Q2, Q3 divided by 4 pi epsilon naught into R23. Clear, Nama? So that will be the total amount of work done to assemble the charges at a configuration. And this is nothing but electric potential energy stored in the system. Clear, Nama? That's it. So this is the equation. Okay? Make a note. So understood, Nama? Now see ma, if you see this formula carefully, what do you understand? ఫార్ములా అర్థం చేసుకోవడమే గొప్ప విషయం సార్, చూస్తే ఇంకేం అర్థం అవుతుంది మాకు. వావ్. ఇంకా స్టిల్ ఇఫ్ యూ లుక్ అట్ దిస్ ఈక్వేషన్, వాట్ డూ యూ అండర్స్టాండ్? వాట్ వీ అండర్స్టాండ్ ఈస్ దట్, సీమా వీ హ్యావ్ అరేంజ్డ్ 3 charges, no? 3 charges. So if I am taking 3 charges, every pair is present here, no? Okay? 1, 2 will form one pair. 1, 3 will form one pair. 2, 3 also will form another pair. So, number of terms which we have to write depends on number of pairs. This is one point which you should remember. Okay? See, for example, if I take only 2 charges, if I want to arrange only 2 charges at a configuration, then how many pairs are possible? ఇది లాగడానికి ఎవరన్నా నా అసిస్టెంట్ని పెట్టుకోవాలరా బాబు. 2 charges. క్యాబ్ పెట్టకపోతే ఆరిపోతుంది ఇది. సిమా, ఇఫ్ ఐ ప్లేస్ ఓన్లీ 2 charges, this is Q1 and this is Q2 and this is the separation between them is R, then how many pairs are possible? Only one pair is possible, no? So therefore, what is the electrostatic potential energy stored between the charges? Q1, Q2 divided by 4 pi epsilon naught into R. That's all. This is my formula. Understand? Because there is only one pair. Similarly, if I take 3 charges, okay? What are the 3 charges? First one, second one, third one. Clear, Nama? Charge Q1, charge Q2, charge Q3. So this distance is R13, this distance is R12, this distance is R23. Then here already we have written the formula, no? How many pairs are possible? Clear, Nama? So this is one pair. Clear, no? So 1, 2 they will form one pair. 2, 3 will form second pair. 1, 3 will form third pair. 3 pairs are possible. So we got 3 terms there. Are you able to understand? Similarly, if I take 4 charges, 4 charged system, 4 charges are present in a configuration. Clear? So consider this is one charge, second charge, third charge and fourth charge. Clear, Nama? So Q1, Q2, Q3, Q4, 4 charges. Okay? So distance between 1 and 2, let us call it as R12. This is R24. This is R34. This is R13. Still 2 pairs are possible. This and this is also possible, no? Clear, Nama? So if there are 4 charges, 6 pairs will be possible. Are you able to understand? No? So likewise, depending on number of charges, you have to write the number of equations. That's it. Number of terms in the equation. Are you able to understand? No? So 1, 2, 3, 4, 5, 6. 6 pairs are possible. Okay? That's it. So number of pairs, you can write this equation, ma. number of pairs possible. You can write n into n minus 1 by 2. This equation also you can use. Same equation we have used in atoms also, no? Same formula we can use here also. For example, if there are 4 charges are present, then number of pairs are how many? Number of pairs are 4 into 3 by 2. 6 pairs are possible. So therefore in the equation you should write 6 terms. Okay? That's it. See ma'am. So see this question. Point charges are located at 2 vertices of an equilateral triangle. Clear, no? So here consider, here there is a charge of 3 into 10 power minus 9 coulomb, and here also we have a charge of 3 into 10 power minus 9 coulomb. Clear, no? So what is this side? This is 20 centimeter, 20 centimeter, and this is also 20 centimeter. And there is a test charge somewhere at infinity. Here there is a test charge, and what is its value? 10 power minus 9 coulomb. Okay, ma? So this test charge I want to bring from infinity to this third vertex of this equilateral triangle. Clear, no? Then the question is how much work will be done. Okay? Work done, what is the work done? If I call this point as point C, potential at point C multiplied by charge which you are moving, that's all. This is the amount of work done, no? Okay, ma? Work done is what? Work done is nothing but potential existing at this point multiplied by the charge which you are moving. That's all, no? So at a point C, who will give the potential? This charge and this charge. Both of them will give the potential, no? Clear, no? So just add them. So here, because of this charge, what is the potential, ma? Q divided by 4 pi epsilon naught into R. Okay? And this charge is also same charge, no? So again I will write same Q. Q divided by 4 pi epsilon naught into distance is also same, no, ma? So again R only. Now multiplied by which charge I am moving? I am moving the charge of 10 power minus 9. Okay? Just substitute the values. So 2Q divided by 4 pi epsilon naught into R multiplied by 10 power minus 9. Okay? So 2 into charge is how much? 3 into 10 power minus 9 divided by R value is 20 centimeters, so 0.2 meters. And 1 by 4 pi epsilon naught, how can I write? I can write 9 into 10 power 9 multiplied by 10 power minus 9. That's all. Clear, no? Do this total calculation, you will get the answer. As 11 on the resident card. అదే నన్ను చెప్పింది అయితే కరెక్ట్ 2.7 into 10 power minus 7 2.7 into 10 power minus 7 joules. That is the amount of work. Clear, no? See, ma'am. See this question. So distance between two protons is, so consider here there is one proton, ma. Here there is one more proton. And what is the distance between them? Distance between them is 10 power minus 10 meters. Clear, no? So if they are made free, it means if I release them, what happens? Because of repulsion, they start moving away from each other, no? Okay? So if they are moving away from each other, they will gain kinetic energy, no, ma? Who gave that kinetic energy? Adi kada question. One energy should be converted into another form, no? Law of conservation of energy lo em chadinarra? Energy is converted from one form to another form. You cannot create energy. Clear, no? So if they are getting separated, it means they have kinetic energy. So somebody gave them kinetic energy. Who gave them the kinetic energy? Potential energy is stored between the charges. Clear, no? When these two charges are present at this separation, they have some potential energy between them, no? How much potential energy they have? Potential energy is equals to Q1 Q2 divided by 4 pi epsilon naught into R. This is the equation, no? So just do it. So therefore, what is the charge, ma? 10 power. Charge of proton is how much? 1.6 into 10 power minus 19. Q1 Q2 is there, no? Whole square divided by 4 pi epsilon naught into, what was the initial distance between them? 10 power minus 10. This is the initial potential energy between them. Clear, Nama? So therefore, if I do this calculation, so potential energy is equals to 1.6 into 10 power minus 19 whole square, and 1 by 4 pi epsilon naught can be written as 9 into 10 power 9, Nama, multiplied by 10 power minus 10. So this is the total potential energy existing between the charges. Now this energy will be converted into what? It will be converted into kinetic energy of 2 protons. How many protons are there? 2 protons are there. So first proton will have Sima. For example, let us consider this proton has reached somewhere here, and this first proton has reached somewhere here. So here it will have a velocity of v, here it will have a velocity of v, when they are at infinite separation. Infinite separation means what? Now there is no force of attraction or repulsion between them. They are at infinite separation. It means total potential energy converted into kinetic energy. Kinetic energy of how many protons? 2 protons. So therefore, what is the kinetic energy of each proton? Kinetic energy of each proton. So this is equals to this total energy divided by 2, that's all. That's all, no? Because this energy is not converted into kinetic energy of single proton, no? It is converted into kinetic energy of 2 protons. So kinetic energy of each proton is half of this one. So therefore, it is 1.6 into 10 power minus 19 whole square multiplied by 9 into 10 power 9 multiplied by 10 power minus 10 divided by 2. That's it. Okay. So if I do this calculation, it is 2.3 into 10 power minus 18. This much energy you should get for each proton. Fine.